apologize all the participants for the delay because of a technical glitch. We're going to start the session once again. Thank you, God, for blessing us more than we deserve. To all the participants, artificial intelligence will be part of our future. It's inevitable. So that time. We will start our day 5, session 1 with the topic hands-on with NLP. The keynote speaker for this session is Mr. Shrikant Jerry. Mr. Shrikant completed his MTech Computer Science in the year 2013 SGBIT BTU Belagavi. He completed his MBA HRM the year 2017 Amity University Noida. He is pursuing his PhD in modeling the cognitive theory of depression using sentiment analysis-based methods, MSRIT BTU Belagavi. Professional experience. Working as Associate Principal Data Scientist in Accenture AI. Worked as Technology Consultant in Exclamatory Labs Private Limited, Bangalore. Worked as Assistant Professor in MSRIT, Bangalore. Worked as Technology Consultant in CIP Private Limited, Bangalore. Worked as Assistant Professor in Presidency University, Bangalore. Worked in Reva University, Bangalore as Assistant Professor. Worked in Trim India Software Services Private Limited, Bangalore as a software developer. Software copyright. Software titled Message Recommendation Feature for Messenger Applications Using Sentiment Analysis is copyrighted in Copyright Office, Government of India. Patent. Invention titled Cognitively Managing Depression Levels in an Individual is published in Patent Office Journal, India. Data repository. Dataset titled Cognitive Triad Dataset, Understanding Beck's Cognitive Triad Mechanism in an Individual from Social Media Interactions is published in Mentally Data Elsevier publications. Aspect-based sentiment classifications for detecting the cognitive triad mechanism of depression, Journal of Computer Science. Data set for modeling Beck's cognitive triad to understand depression in data in brief, elsewhere. T5W, a paraphrasing approach to oversampling for imbalanced text classification, 2022 IEEE International. IEEE International Conference on Electronics, Computing and Communication Technologies. Analysis of RNN capsule model for multi-class imbalance data. Singapore, Springer. Deep learning based architecture for social anxiety diagnosis. 2020 IEEE International Conference on Electronics, Computing and Communication Technologies. 2020. Profile summary. Working experience in natural language processing capabilities like question answering, named entity recognition, text summarization, text classification, conversational AI, aspect-based sentiment analysis and prompt engineering. Work on NLTK, NL Pretext Gensim, Generative Pre-trained Transformer GPT-3, Hugging Face Models. Sir, I welcome you for this session. I welcome the keynote speaker. I request Mrs. Sabhavana to administer our keynote speaker. Sir, please. Thank you, sir. Thank you, madam. Over to the keynote speaker. we are exploring some of the packages with respect to NLP. Those are NLTK, Natural Language Toolkit, and NL Pretext. Fine. These are the contents which I have planned for this session. Introduction to NLP, Natural Language Toolkit, NLTK package installation, uh, tokenizing words and sentences, stop words with NLTK, stemming words with NLTK, sentiment analysis using NLP, and I will go through NL pretext. Okay, if time permits, I will go through one of the case study on sentiment analysis, which is product rating on e-commerce side. So, what is NLP? NLP is the technology used to help the computers to understand the human's natural language. Okay, it can we know that we have learned many programming languages like Java and all. So those are the programming languages. So whatever we talk, okay, whatever we talk in our human language, our computers should understand. Our models, our machine learning or the deep learning model should understand that. Okay, that the same purpose we are using natural language processing to understand the humans' natural language. Natural languages are like English, Kannada, whatever the human languages. Okay. So what this NLP does, it is used for like analyzing and synthesizing the natural language. One of the example here is like you have seen IMDb movie rating website, right? Whenever you want to go for a movie, you will search the rating of that. Okay. Suppose I want to know the rating of Kantara movie. Okay. How exactly? Suppose your rating will be seven. A movie rating will be a 7 out of 10 or 5 out of 10. Okay. How they will provide the rating there? Is that a biased one? Like directly they will arrive with some number? No, right? So based on the user's reviews, whatever the user has given, users has given the reviews, based on that, they have arrived with the rating, correct? So these are in the basically whatever the comments or the feedbacks on the movie is basically a natural language text. For example, you can see the comments there. Kantara movie is nice. It's boring. Yesterday I went to the movie. I enjoyed it. Superb. These four are some of the comments of the users. Okay. So basically, how to the rating? For each of the comments, basically you need to identify the your model need to identify the sentiments, whether it is a positive or negative. Okay. Kantara movie is nice. It's a positive sentiment. Okay, it's boring. It's negative sentiment. Okay, so how to calculate the rating? Like total number of positives divided by total number of comments overall into 10. Right? You will get the rating out of 10. So here the question is how our NLP model understand the natural language comments and find out the sentiment out of it. Okay. So here you can observe some of the comments here. Okay. Kantara movie is nice. It's boring. Here some of the comments will not be contributing towards the analysis of sentiment. Okay. For example, here is it's I went. Okay, these are all some of the words. It will not contribute. You can see only the nouns or the verbs, whatever. Nice. Kantara movie is nice. Nice will give you the sentiment. Is will not give you the sentiment. Similarly, the two. Okay, these will not give. These are part of a grammar, part of the English grammar. Okay, this is the in syntax it will come, but it will not contribute anything towards identifying the sentiments, right? So we need to pre-process our text, because if we take entire text, okay, to train the model or to predict to get the prediction out of the model,
Okay, like it will be like the model size, whatever. If we use all the words, model size will be huge. Okay, and also it requires a lot of time for processing that processing these particular textual data. That's why we need to do some pre-processing steps using natural language processing. Okay, now one of the Python package for natural language processing is natural language, that is NLTK. It's a suite of open source Python modules and data sets for natural language processing. So it is having this particular package is having resources like dictionaries in multiple languages, stop words in multiple languages. It is having some articles for doing the experiments, for training them, training our machine. So it is having a lot of resources. So to install this package, this is the command we use: pip space install NLTK. Those who are doing hands-on, you just install this particular package using this particular command: pip space install space NLTK. NLTK is the package name here. And there are it is not only sufficient to install the package. You need to download the resources. Okay, as I said, whatever the language dictionaries are there, stop words, language stop words are there, those you need to download it. For downloading that, there are two statements here. After installation of NLTK, you need to import that NLTK and you need to run the function NLTK.download. This particular NLTK.download, it will install it will download all the resources. Okay, it is very huge. It takes a lot of time. So what we will do is whatever the resources we require for our and some then and then we will download and use those resources. Okay, how many of you have worked on Google Colab? Anybody? Okay, or you have Python installed in your system, right? Okay. Otherwise I will tell you how to okay, but it takes time. Okay, anyway, we will start with uh, package installation. So are you using Spider? Or which ID you are using in your okay, what is the Anaconda is fine. What is the ID uh, edit editor you are using?
Ideally with 3 words.
Yes, any of Jupyter Notebook. Okay, okay. Anyway, then this is same as whatever the Google Colab is there. It's similar to Jupyter Notebook only, but this is provided by the Google. Okay, yeah. In the you in the code cell, in the first code cell you install the NLTK package. PIP space install space NLTK. You run this particular package. Any help you needed? Okay. All of you you have to download this particular resource PUNKT, okay, and averaged perceptron tagger and stop words. You need to download these three resources, okay, because we need part of speech tagger, we need stop words, okay, all this we require, all these resources we require it, okay. So we download these three resources, okay, using the download function which is there in NLTK, which is defined in NLTK, okay. So I will run this particular cell. I will tell you where these resources are used. Let me know when you finish this. Okay. Anybody who has completed these two steps? You can use Google Colab. Colab. Okay, done. Now, the first step is part of speech tagging. Okay, listen here. One of the more powerful aspects of NLTK module is part of speech tagging. It will label all the words in a sentence as nouns, adjectives, verbs. Okay. Basically, it will attach part of speech tag to each of the words in the sentence. Okay. For example, you can see here the sentence given here is they permitted us. Correct? How many tokens are there or how many words are there here? Three words. Okay. They is the first word, second word is permitted, third word is us. Right? So, what is the part of speech for they? It is PRP. PRP means personal pronoun. They is a personal pronoun, right? So, it will attach part of speech tag PRP to the word they. And what is the fine? Okay. Now, this is the code to attach the part of speech for each of the words in the given sentence. First, I will import NLTK, and then from NLTK import word underscore tokenize. We are using some of the functions in NLTK here, which are word underscore tokenize and POS underscore tag. These two functions we are importing from the package NLTK. Fine. I will tell you why we are using those two functions. Here, whatever the input is there, he is going to college. This is the input sentence. Okay, I want to tokenize into list of words. Okay, list of words. It is basically a sentence. I want list of words. Okay, so to convert the given sentence into list of words, we use function word underscore tokenize. Okay, now to this word underscore tokenize function, I will give input as he is going to college. Now it will convert it to this particular function will return the list. Okay, so text is now what is the data type of text? It is a list, right? So if I print this particular text, okay, print list of words text, it will print this particular list. You can see the first word is he, second is, okay, this list of words it will provide. Okay, it is there in which variable? Text. Fine. Okay, now I have to attach part of speech tag for each of the words in a given sentence, right? So I will use the function pos underscore tag, part of speech underscore tag of what is the input for this particular function? It's a list of words. That is text, variable text. In variable text, we have list of words, right? Yes. That we will give it as an input to this particular part of speech tag. Okay. Now, if I display that, okay, if I display POS tags, you can see here he is attached with PRB, personal pronoun. He is attached with BBZ. Okay. Next, going is attached with VBG. Like this, it has attached all the uh, attached POS tags to all the words in the list. Any doubt here? 5 we use word underscore tokenize. It will convert the given sentence into list of words. Okay. What is the purpose of using POS underscore tag? It will attach part of speech tag to each of the words in the given list text. Okay. Fine. Now, tokenizing the words and sentences using NLTK. Okay. Here, there are two kinds of tokenization. One is splitting words, and the other one is splitting sentences. Okay. So here there are different kinds of splittings are there. Here, first one is word tokenizing, word tokenizer. Unique. This is also called unigram, converting the given sentence into unigrams. In same thing, whatever we have used word underscore tokenize, we are using it here. Okay. So here, how to convert given sentence into unigrams? Here you need to import the word underscore tokenize, which is there in the NLTK. Okay, from NLTK, import word underscore tokenize. Next, in the text, we have in variable text we have John works at Intel statement. Okay, it's a string. John works at Intel is a string which is stored in the variable text. Next, we we want to convert this into list of words. Okay, word underscore tokenize of text will convert that into list of words. Whatever the sentence you have given, it will convert it to list of words. Okay. If you print that, you will get the unigram. Same thing. Like a unigram means splitting. You have only one token in each of the item. Okay. You will come to know what is bigram, what is trigram. Okay. So in bigrams, suppose I will tell you what you have to get it first. Listen here. Here the sentence is John works at Intel. Okay. So what is bigram? You need to consider two consecutive words in bigrams. Okay. John works. John works is first bigram. Two consecutive words. Next, works at is the second bigram. Third bigram is at Intel. At Intel. Fourth bigram is Intel full stop. Okay, these are the bigrams. Okay, so how to get this particular list of bigrams using the function bigrams which is there in NLTK. Okay, from NLTK import bigrams. From NLTK import word underscore tokenize. We need this word underscore tokenize throughout because first we need to tokenize the given sentence into list of words. Then only you can convert it into bigrams by calling the function bigrams. Fine. Okay. Now what is there in the text variable? It is this particular statement. Okay. Now tokens equals to word underscore tokenize of text. This list of we need the input to word underscore tokenize. Okay. In the tokens we have list of words. Okay. For bigrams function, you will input this particular tokens list. Okay. And you apply the you convert that into list. Okay. You are doing some typecasting here. Now that will be stored in this particular variable lt underscore bigram list underscore bigram. Any doubt here? First, what you have done, you have converted the given sentence into list of words, and you have given that particular list as input to bigrams function. Okay, it has converted the it has consumed the list of words and it has got the bigrams. Okay, now you are typecasting it into list. Okay, to get the list of bigram. If you display this lt underscore bigram, you will get this. Clear? What is bigram? Bigram is a two consecutive words. Okay, bigram is two consecutive words in the given sentence. Okay, you are arriving with all the bigrams in the given sentence. Similarly, trigrams. Instead of bigrams function, you use trigrams. Okay, so here you import the trigrams. Okay, and use trigrams function here. This is the only change. Okay, so what is the given a sentence John works at Intel. What are the trigrams here? John works at his first trigram, works at Intel, second trigram, and the third trigram is at Intel full stop. Okay, this is the first trigram, second trigram, and third trigram. Sometimes you need to train your machine using bigrams and trigrams as the features. That's why in the pre-processing, in the NLP pre-processing, you are learning these concepts: unigrams, bigrams, and trigrams. Okay, that is the purpose of learning here. Okay, next comes sentence tokenization. Suppose given a sentence, given a string, it is having multiple sentences within it. Okay, you can divide the entire paragraph or an entire string into list of sentences. Okay, here for that purpose we use sent underscore tokenize function. Okay, we import sent underscore tokenize from nltk.tokenize. Tokenize is a submodule in nltk. Okay, this is a submodule. In that there is a function called set underscore tokenize. What this will do, given a string or given a paragraph, it will convert it into list of sentences. Word underscore tokenize or convert the sentence into list of words. Okay? We can convert it into list of sentences. That is the difference between word underscore tokenize and sentence send underscore tokenize. This is the example sentence, example text. You can consider 3 to 4 sentences within this particular string. Now, send underscore tokenize of example underscore text. This example underscore text we give the input to this particular function send underscore tokenize. Now, it will create the list. Okay, get the underscore send is the list of sentences. Now, if you print this sentence list, it will give you list of sentences. Okay, I will show you the output here. Okay, whatever this statement is there till question mark, this is the first item. Okay, second, the weather is great. Okay, whatever this sentence is there, second sentence, this will be the second element in this particular list. Okay, and followed by the sky is pink is this particular sentence. Uh, is the third item. Okay, in total there are four sentences are there. Okay, you will have 4 elements in the list. Okay, so now next comes stemming. Stemming is a sort of normalizing method. Okay, if you consider these words, market, markets, marketing, marketed, and marketer. Okay, here the root word is market. Just the tense is involved in marketed and marketing, right? Okay, so stemmer removes morphological affixes from the words. This is to decrease the number of tokens to be trained. Okay, in your dictionary, English language dictionary, you don't have the word marketed, right? You have the word market, okay, and also you don't have markets. Plural form is also not there, right? So tenses and plural forms will not be there in the dictionary. Okay, only to reduce the dictionary size, we use this particular stemming dictionary. Okay, now here you need to import total stemmer class, okay, which is there in nltk.stem. Okay, you need to import this particular class which is having the stemming functionality. Okay, so before using that particular function stem, we need to create the object of this particular class, right? Because you cannot directly call the function inside the class. Okay, you need to create the object first. Because is the object of your class total stemmer. Okay, now I have taken list of words in the variable example underscore words. Market, markets, these are all the words here. Now I want to get the stemming word. Okay, stemming word from all these given tokens. Okay, so for W in example underscore words, I am iterating this particular list. I am iterating the list example underscore words. Okay, each word in the iteration will be in the variable W. Okay, so ps.stem of W. What is the first W value? It is market. It will be market only. Okay, and next word, next W value is markets. Okay, what is the stem word for that? It is again market. Okay, for all these words you will get the market as the stem word, right? You need to remember the class name, porter stemmer, and the function name that is stem. This stem will take input as a string. Okay, you can see the output here. In all the cases, you got the same result, that is market. Only to reduce the dictionary size, okay, while training, we use this particular stemming functionality. Next comes stop words. Okay, stop words with NLTK. Here, as I told in the beginning, when we want to train the machine with our data, okay, most for sentiment analysis, for example, okay, some of the words will not be useful for it will not contribute anything towards identifying the sentiments, right? Those words are called stop words. Okay, for example, the ourselves. These words are not having any sentiments, right? So we want to remove those words, okay, before processing the text. Okay, these commonly used words are called stop words, right? So these are the comments we have seen after removing the stop words. This Kantara movie is nice. You will get it as a reverse text as a Kantara movie nice. It has removed is. Okay. The next statement, it has removed its. In the third one, it has removed all the words except movie enjoyed. Okay. In the fourth one, super. In the fifth one, movie. Only these words, which are contributing to the contributing to identify the sentiments will be related. Okay, so we have reduced the size of the text, size of the tokens before training. Okay, here there are we need two functions here. One is stop words and the other one is word underscore tokenize. Okay, we include those two functions. In example underscore sentence, we have the text statement. Okay, and now what next step is what I will do. I will get the stop words of English using this particular function words which is there in stop words. Stop words got words of English. I will provide the language, okay, language where I want to use the stop word of particular language. Okay, I will convert it to set. Okay, and this particular stop underscore words now is having list of all the stop words in English. Okay. Now what I will do, whatever the example underscore sentence is there, okay, I will convert it into list of words. Okay. I am using the function word underscore tokenize. Now this particular word underscore this particular variable is having the list of words. Now I will get the I will remove the stop words here. This is the shortcut this comprehension. Okay, these two functionalities are same. Okay, so here I will consider an empty list filtered underscore sentence for W in word underscore tokens. Whatever whatever is there in this particular word underscore tokens list of words, I will consider one by one for W in word underscore tokens. Okay, if not W in stop words, if that word is not there in the stop words, then only I will append this to filtered underscore sentence. Means here I am considering only the words which are not the stop words, and I will append it to filtered underscore sentence. These two functionalities are same. It's a shorter notation. And finally, I will print the filtered words. Okay, these are the list of words which I got it from word underscore tokenize function, and here, these are the filtered words. You can see here, it has removed this. It has removed is. These are the stop words. It is also stop word. Okay, sample it has retained. Sentence is retained. Okay, all the stop words are removed here. All the commonly used words are removed. Okay, any doubt here so far? Any doubt? And what is the hard deadline? Okay, now you have seen the NLTK package, which is used for pre-processing the uh, generic data. Okay, now there is one more package called NL pretext. Okay, this is used for pre-processing the social media data. Okay, what is the specialty in what is the specialty in social media data? It is having mentions, it is having hashtags, it is having images. Okay, sometimes you need to remove those particular entities. Okay, for that purpose we use ML pretext package. To install this package, you use the command pip space install space NL pretext. Okay, this is developed on top of MLTK package. Okay, there are multiple pre-processing steps, lower casing the given text and removing the hashtags, removing the mentions. Okay, and removing the punctuations. These are all the different functionalities in natural language processing. Okay, now if you don't know in which order you have to go, okay, you don't know the pipeline, okay, then you can use the default pipeline here when you don't know how to proceed with it. For example, I will tell you why it is required. Like suppose from the given sentence, okay, you want to remove the punctuation first and then hashtags. There is a hashtag called hash social media. Okay, if you remove the hash initially itself, you cannot remove the hashtag, right? Only social media will be remaining. Okay, so it will not recognize it as a hashtag. Okay, that's why what you have to do first, you have to uh, remove the hashtags. Okay, then you have to remove the punctuation. If there is a full stop, then you can it will remove it after removing the hashtag. Got it? So when you don't know that, you have to use the uh, default pipeline. So you need to import the preprocessor class, okay, from NL pretext package. Okay, and here in the text variable you have the given text. Okay. Now what you have to do? You have to create the object preprocessor of the class preprocessor. Now I will call this particular run function using this object preprocessor. And what is the input for this run function? It's a given text. Okay. Now, if you display this particular text, okay, which is the value is returned by this particular run function, it will provide you. You can see here. I just got the best in my life. Okay, here it has removed the mention. This is the mention, right? It has removed, and also it has removed uh, this emoji, and it has written hashtags, hash code, hash Paris. Okay, it has removed these. Okay, so here it has done pre-processing based on its default pipeline. Now, suppose I want to use my pipeline. Okay, I want to specify um, the functions in order which I want to do. I can do it here. So I will import preprocessor again, and there are multiple functions I am importing from getPretest.basic.preprocessor. These are the basic preprocessing functions I will import it, normalizing the white space, removing the punctuations, removing the end of line characters, removing the stop words, lowercasing the text. Okay, these are all the basic functionalities. I will import it. Next, specific to social media data, I have some functions like removing the mentions, removing the hashtags, removing the emojis. Okay, these are all the functionalities related to social media data. Usually we have these mentions, hashtags, and emojis in social media data. Okay. Now, after importing all the required functions, okay, what I will do, I will whatever in this particular text we have the given text, okay, and now I will create the object of this particular class preprocessor. Now, in the pipeline, I will put all the functionalities in the order, okay, in the order which I want to. Okay. Preprocessor dot pipe. In the pipeline, first I will put lower underscore text. Means on top of this data, I have to apply this particular function lower underscore text. I have to lower case this particular text. Okay. Then remove underscore mention. It has to remove the mention. Okay. Only one mention. It will remove this particular mention. Next, remove the hashtags. Okay, it will remove hashtags, put and paris, and remove the emoji. Emoji it will remove. Remove the end of the line characters. Any new line characters it will if you have it will remove like slash and it will remove. Next, remove the stop words. Okay, you have to specify the language here. In which language? What is the language of the text? Given text. It is English language. Okay. Next, I will put remove underscore punctuation, normalize underscore white space in the pipeline. Okay. All these functions are in the pipeline. In which order you have to run on the given. Okay. Now what I will do, I will call this particular run function preprocessor dot run of text. Okay. And this particular text, whatever we have, this particular input text, we will provide it to this particular function. If you display this, you will get the pre-processed text in the order which we have specified. Dinner life recommend. This is the output after pre-processing using all these functions. It has removed emojis, it has removed mention, it has removed punctuation, it has removed um, hashtags. Okay, this is the custom pipeline. Okay, if you don't know in which order you have to go, you have to use the default pipeline. Okay, now some of the if you are working on medical data, okay, medical data, then you need to sometimes you need to mask the email IDs, mask the patient's information in the data. Okay, before training, you need to mask the user information. In that case, what you have to do, you need to replace the emails by some external email. Okay, you have to mask those emails and email IDs and other mobile numbers, other information. Okay, so replacing emails is the first we will take it first. From NL3 text we have basic dot preprocess import replace underscore email. Okay. In this one we have this particular sentence which contains the email ID. Now I will call this particular function is underscore emails. The input of this particular function is example. To replace that is the token which I want to uh, email ID. Okay, star email star. So if you can see after applying this particular function on this particular example text will get this. I have forwarded this email to place of this particular email ID. It is provided this particular. Similarly, there is one more function called index_phone_number. You can use this to replace the number with this particular token. Okay. So after pre-processing, after applying this particular function, you will get this particular node. My phone number is, it has marked this particular phone number. Next, remove the hashtags. So here you need to import remove underscore hashtag. You need to import from nlpretext.social.preprocess. And here example is given which contains example text which contains hashtags. Okay. So there is a function called remove underscore hashtag to which you give the input as example. You can see here the pre-processed text. It is having this restaurant was amazing. It has removed all the four hashtags. Okay, this particular function is remove underscore hashtag is to remove the hashtags from the given. Next, extracting the emojis. Suppose you want to know the meanings of emojis. Okay, for emotion analysis, we need like a meanings of the emojis. In that case, you use this particular function extract underscore emojis. In the example, I take care of my screen and there is a emoji after that. Correct? So if you pass this particular example variable for extract underscore emojis, it will extract the meaning of the emoji. Okay? It's a great fix. Right? Now, you know what is stopwords removal, right? There is in NL pretext also you have the function called remove underscore stopwords. Here in the example variable, I am listing out all the words I like when okay these are all the words I want to remove the stop words here from the list of words. Here to remove underscore stop words function, I will give the input as example which is the list of words and I will specify the language as English. If you apply this particular function, you will get these words which are not the stop words. Right? Okay, this is all about INN pretext package. Here in this session, we have learned, I have introduced what is natural language processing, and we have explored two packages, NLTK and NL pretext. NLTK is for general data, and NL pretext is for social media data. And this NL pretext is developed on top of NLTK. Thank you all.
all the participants. Welcome to session 2. Topic is a practical implementation of generative AI. The keynote speaker is Mrs. Grace Priscilla Nambi, System Architect and Product Owner, Hewlett Packard Enterprise. Grace Priscilla is a passionate in the R&D division of the Communication Technology Group of HP Enterprise. She has an overall industry experience of 18 years. Currently, she is an architect and product owner of a telecom platform and is interested in the new technologies of the telecommunication industry. She has a strong passion to work among students and has been mentoring the final year projects of IIT students. She has two branded patents and has more papers filed for patent grant. In addition to this, she has written multiple research disclosures. Her hobbies are music and singing. We welcome you, ma'am. Over to the keynote speaker.
Thank you so much for the introduction, and I'm happy to see you all here. So the title given to me here is Generative AI. I'm sure that for the past 1 week, all of you would have been drilling yourself in artificial intelligence. So most of the topics would have been covered is my assumption. But I'm going to give you a brief overview of generative AI and what are the internal algorithms that are used in generative AI. I want it to be an interactive session. I hope no one sleeps or is meddling with the phone. So, uh, okay, let me introduce myself. So already introduction has been given. So I did my electronics and communication engineering and passed out in 2005. And after that I did my MS and now I'm working in Hewlett Packard as a product architect and I'm doing a lot of implementation and development related to the telecommunications sector. So I know all of you are interested in telecommunications sector and it's my passion for many years. Understanding the various multiple 4G, 5G and going to be 6G technologies and that is my area of expertise. But now you have artificial intelligence and generative AI coming up, which is actually taking most of the market space. So let me just give you the agenda of what I'm going to share today. So this is what I prepared. I do not know how it will go. So I'll be giving an introduction overview, which will actually ponder around all the thoughts that you have studied around generative AI and artificial intelligence. And then I'll be giving a glimpse of the pros and cons of the usage of generative AI. And I'll share some of the algorithms and models, which is actually the procedure. And we'll have a small practice. I don't want to get into the code internals. I believe most of you have a Python coding knowledge and you can write your own code in Colab Research and you can try it yourself. So I don't want to get into the line by line details of the Python programming, but I would like to show you a small sample of how the generative AI works. So, have any one of you thought? Can you please? I want everyone to be interactive. So, can any one of you have given an insight why this AI is taking the market? Why is AI being so common today? Anyone has given a thought? Okay, I know we all have moved from a physical ease era wherein people have been moving out of physically exerting work. Like you have in the past seen people washing with your hands. Today, what are they using? Washing machine they are using. Why is it so? You want to ease your physical work, right? And also you have seen people working in the kitchens very, very hard in the past. Today, what do you have? So what has made you literally physically a bit lazy? So people, I think when I see this artificial intelligence and generative AI coming up, I always have intuition that people want to become mentally lazy as well. So they don't want to think for themselves. They want something else to do the thinking also. So that is where we have the first innovation. Do you anyone of you can guess what this is? A calculator, which is one of the main innovations that started up because people don't want to calculate themselves on their with their brains. So people are scared of maths exams because they don't want to think and calculate. So they offloaded their mental calculating capabilities on machine. So someone will say 2 plus 2 is 5. So will calculator say 2 plus 2 5? No, why? Because it is fed with an intelligence. Who fed it with an intelligence? So that has made their life easy. So you'll never make mistakes. You have offloaded your work to a machine. Okay. So that is one aspect. So starting from calculator to today, what do you have? Artificial intelligence. So you want all your thinking to be done by the machine. You don't want to think yourself and do. So what you are doing? You're just feeding all data into the machine. And what are you expecting from the machine? You want the machine to do what you are doing. Don't that do you think that's making you mentally lazy? In what way is it making you lazy? Okay, I will just before going to the history of AI, I want each of you to think what is artificial intelligence and generative AI doing today to the society? Is it lazing you or is it making you more smarter? So that is something. Okay, some of you are saying lazy. Can you see the hand that says it is making you more smarter? So all of you who is making you lazy, all of you lazy. Okay, so all of you are for AI or generative AI. So what do you want to study? You can think with your own head, right? But that's not a fact. So calculator has eased so much of your job. Similarly, generative AI is going to ease a lot of your job. So that's the reason today's world is moving towards AI. So the first AI was actually invented in the year 1943. So where someone thought, why don't we make the machine think like man? So in your head, the brain has a lot of, what do you say, neurons. So these neurons are interconnected. So what does the neurons do? I can say that this is a mic. I can look at the chair and say that's a chair. How do I say that? What makes me say that? Who told me that's a chair? Your neurons in the brain is telling you, right? It's making a probability. This could be a chair because I learned I can sit on it or someone told me about it.